And welcome back. We're going to be talking about sets and compound inequalities today. Let's look at our different sets. Now, if I were to look at the definition of a set, I would say that it is just a collection of objects or things. More specifically, in mathematics, we have to say what those sets are. So let's look at, oops, I need a brush here. Alright, so let's look at our different sets. I have a set X, I have a set Y, I have a set A, I have a set B, a set S, a set T, and a set V. These different sets are typically designated with a capital letter. These sets have things in them, and those things we are going to call elements. So for instance, let's just look at set, how about we look at set X. So for set X, the elements in set X are usually represented in these curly Q brackets, and then you just list them and with commas in between, E, A, and R. That would be a listing of the elements in set X. And now these elements can be numbers, letters, anything of that sort, just a collection of objects. If I were to talk about the elements, let's say in set V, let's go down there to the bottom. The elements in set V would be Drew, Jade, and Glenn. And I just list those things off, making sure that they are in the curly Q brackets. For a set to be a subset of another set, every single element in that set must be in the other one. So let's look at X and Y because that's classic. Let me go ahead and write the elements in Y because that would make it more clear, I think. Everything that's in X is also in Y. See how X is contained in Y? So Y has both the E, the A, the R, but it also has a D. So I would say that if I was looking at the notation, I would write it as, since X is inside of Y, I would say that X is a subset of Y, and that notation right there represents subset. We don't really have any others that are exact subsets, so we'll just let that go for now. Let's go ahead and go on to the empty set. The empty set means there's nothing inside. Don't really have one of those, so I'll just make one up. Let's just say I have this set W, and there he is. He's got nothing inside him. The empty set is represented sometimes like curly Q brackets with nothing inside. It also can be represented with a zero with a slash through it, meaning that there's nothing on the inside. So the empty set is actually contained in every single set. You can see there's empty space in all sets. So that empty set, or the nothing element, is in every single set. So let's look at union. Union means what's in both. So if I were to write X union Y, I would say that that equals, and let's write all those elements that are in both of them. So that would be E, A, R, and D. And you could also say X union Y equals Y. That would be a true statement. Let's do, how about S union T? That would be, got to write them all, so that's what's in everything. Alex, Hunter, got to write everything that's in S. Casey, Drew, Jade, because that's in T. I think I got everything. There should be 5 of them. Yep, there we go. So there would be my union of S and T. If I were to write A union B, I would list all of those numbers. Don't want to do that. So let's do intersection, because that's what's common to both. So if I did S intersect T, and this upside down kind of horseshoe looking thing means intersection, S intersection T would then be, what do they have in common? That would be Casey and Drew. If I were to look at A intersect B, I want to do that one because that one's not quite as much. That would be 6 and 12, and I'd be happy there. So that's our set notation. We just have a few new symbols to learn. If you see that symbol, it means subset. Either of these two symbols means the empty set. If you happen to have, let's say you happen to have a set W and you have a set, let's call this one Z, and let's say Z has a 5 in it, and if you were to ask the question, what is W intersect Z, what do they have in common? Nothing. So you would write the empty set. So that is kind of a further explanation of that notation. And now we're going to go on to compound inequalities, and we will be using these union and these intersection symbols. Union, you could also say that this is the word or. You can use that in place of union if that helps you. And for intersection, you can say that that is the word and. So what you're saying is these elements are in X or Y, and if I go over here to S and T, Casey and Drew are in both S and T. Alright, so let's move on. Alright, let's do something new. We're going to use these symbols now to do some math. Venn diagrams will come up every now and then in your math courses, especially if you take a set theory class, then they'll be all in there. But if not, you're basically just using those symbols to now do inequalities. So let's see what's going on with this. It goes from -2 to 1, so I need to write these numbers in order. I usually like to give a couple on either side. Whoops, get a better pen. Okay, went ahead and got those things on there. So let's look at this. So my answers, which is what these are eventually going to be, my answers can either be anything less than -2 or they can be greater than -1. So let's see what that looks like. I'm going to have a squarey guy bracket here for this -2, and it says anything less than -2. I just follow that symbol on down. So that's what that one looks like. Or my answers can be anything greater, squarey guy bracket again, all the way down this way. So my answers, which is what this is going to end up being, can be anything that is less than -2 or greater than -1. So that's what this looks like. This, of course, is my line graph notation, but they're not going to want that. They're going to want it in interval notation. So let's write it in interval notation, because that's really what we're looking to get to. No, that's not notation, notation. Sorry about that. Okay, here we go. So this is my negative infinity arrow. This is my infinity arrow. I just write it straight down. I write down this, negative infinity, comma, -2, squarey guy bracket, or, that's my or symbol if you'll remember. Then -1, comma, infinity. And that's what it would look like. Now this and is going to be a little bit trickier, and ands just are a little trickier. Ors are kind of easy. But ands, let's see what this looks like. Anything that's less than 7. So that would be anything that's less than 7. And I need a squarey guy bracket there. And it also has to be greater than 0. So let's get a different color on that one. We'll do this color here. So anything that is greater than 0 but not including 0. So that would be this way. Then what I need to do is I'm going to figure out what works for both, because both of them have to be part of this solution. So let me write that down. Okay, save you some time there. So where are both of them shaded? So it looks like to me we have both of them shaded. Got a roundy guy there, squarey guy here, and both of them aren't on the 0, just one of them, so I have to use a roundy guy there. But both of them are shaded here. So this is what would be the solution for my answers have to satisfy both x is less than or equal to 7, and they also have to be greater than 0. So the answers to whatever problem it is that I just worked have to be within this area here. And that's what that means. So it really kind of seems weird, because what you're doing is you're figuring out how to write your answers, but we haven't worked any problems yet, so you're thinking, what are we doing here? Well, you're getting ready to work problems, and then this is how you will end up writing your answers. Okay, these are the types of problems that they're wanting us to solve, so let's get busy. These are called compound inequalities, because we have all sorts of stuff going on here. So when I look at this one, I know I want to get the a all by himself. And if I'm going to do something, I have to do it all the way across the board. So I see I have this plus 20 here, and I'd like to get rid of that because I want the a all by himself. So I'm going to subtract 20. And if I subtract 20 there, I have to subtract 20 here and over here. I ask myself the question, am I multiplying or dividing both sides by a negative? If I am, I flip the inequality. I'm not here, I'm just subtracting. So let's just do this all the way across. There's the minus 60. You're gone, little bud. Keep down my same symbol, 20a. 20 minus 20, keep the same symbol, that's a 0. Then I'm going to try and get at the al by himself, divide everything by a 20. Divide by a 20. And did I multiply or divide both sides by a negative? I did not, so I will keep everything the same here. And 0 divided by 20, that's a 0. All right, so let's put this on the graph. All of these conditions have to hold true at the same time, because it says a must be in between -3 and 0. So I put a -3 on here and a 0. Be sure to keep them in order. A must be in between, so both conditions hold true at the same time. This is an and inequality with roundy guy brackets, and shade everything in the middle. They end up wanting this in interval notation, so I would end up with that as my answer. Now, I know everyone tends to get spooked when they see fractions, so let's go ahead and deal with this fraction. If I multiply everything through by a 2, I will basically get rid of that denominator there. So that's what I'm going to do. I multiply everything by a 2. That means everybody's got a double. So let's go. And I'm not multiplying or dividing by a negative, so I just can keep the same symbol. So I've got -4, keep the same symbol. -1/2 times 2 is -1, so I have -1x plus 1 times 2 is 2. Keep the same symbol. 1 times 2 is 2 again. This is much prettier to me than the fraction, so I get to play now with an easier heart. I need to get the x all by himself, so I'm going to subtract 2, subtract 2, subtract 2. Remember to do my addition and subtraction first. That tends to work better. That's going to be -6. Keep the same symbol because I didn't multiply or divide everything through by a negative. This is a -x. You're a 0. And then that, ooh, that's a 0. Now I need to get rid of this -x, so I'm going to divide by a -1, divide by a -1, and divide by a -1. I did multiply or divide both sides, or all sides, by a negative, so I'm going to flip these inequalities, because that's what's going to happen here. 6x and a 0. Oh, better keep that little guy. So this says that x has got to be, notice the symbol, these things, these arrows have changed because 0 is on this side of 6. So x has got to be both greater than 0, so that means this way, and he has to be, notice that the tiny side is towards the x, so x has to be less than the 6, so that goes this way. All these conditions have to be true at the same time, which this works for this guy. And square you got a bracket here. And this answer looks like that. I did another fraction just so that you could watch another one being worked. I'm going to multiply everything through here by a 6. And if I multiply everybody by the 6, chunk, chunk, then my denominators go away, which makes me happy. 6 times this negative 5, 6. That becomes a negative 5. Keep the same symbol because I didn't multiply or divide by a negative. In this case, the 3 goes into the 6 2 times. So all of these guys get doubled. So that's 10x plus 4 less than or equal to, the 6's cancel here, leaving me with a 5. Now if you need any of this explained further, be sure and shoot me an email and I will go over this part in detail. Alright, next thing I need to do is get rid of my 4. So I'm subtracting 4. So I'm going to keep the same symbol because I didn't multiply or divide by a negative. And then your 1. And dividing everything through here by 10. Divide by 10. And when I do that, I then have negative 9 tenths less than or equal to, that's an x, less than or equal to 1 tenth. All right, so now I'm going to put this on my number line in order. I don't really worry that it's a fraction. Then I will put the negative 9 tenths here, 1 tenth, because they need to be in order, and x is in between. He's both less than 1 tenth and greater than 9 tenths. Make a squarey guy bracket. And putting this in interval notation, both of these need squarey guy brackets. 1 tenth. All right. Now you're going to have quite a few problems. They're going to wiggle them in all sorts of different ways. They'll put fractions, they'll put parentheses, just trying to get you in the practice of doing them, just all different kinds of them. So if you run into trouble or if you need any help, be sure and send me an email. That's what I'm here for, and I'd be happy to work through any of those problems with you. Have a wonderful day.